Okay, so OpenACC part 2. So, we are let us do one function which is multiplying A and B matrices and the output is in C. Okay. So, if you recall, we have a loop Cij equal to Aik Bkj sum over k, and this for every ij, right. So, we have, so forget about pragma for time being, just look at the loops ij, this is for every I, every j, and then I am doing the sum over k, right. So, this is a loop for k. Okay. So, this sum is should be done in parallel, this part we would like to do in parallel. Of course, even this loop we want to do in parallel. So, there will be a lot of threads, okay. But look at the k loop first, k loop first. So, for k 0, k equal to 0 to k less than n, k plus plus, I do the sum is initialized to 0. Then after this sum is done, this is done in parallel, avoiding the race condition, because I used this reduction plus colon sum. So, sum will be the sum, this sum for given ij, and then I copy that to C. Now, what is this stuff I star p plus j? Why am I doing it? Yes. So, my array is basically though it is a 2D array, but we save it in 1D array. I am going to come to that after finishing OpenACC. We save this stuff in 1D array. So, this is I equal to 0, then I equal to 1, row 1. Okay. So, we have this matrix, there are rows, no, row 0, row 1, row 2, row 3, you open it up. So, this will be first, then we have these guys, then these guys. So, they are all in 1D array. So, lot of C functions are convert the 2D arrays or 3D arrays to 1D arrays. It has advantage that you deal with single line and memory locality. Okay. For you it is clumsy, you know, I mean I had a matrix, but you give me a 1D line. So, I agree that for a programmer it is not a great idea, but for a compiler or for a computer it is great. I mean I have just 1D line and operate in 1D line and data comes in sequence. So, that is what is done. So, for given ij, where is this element C? So, I star p. Okay. So, p is the number of columns. So, for row 0 this will be 0 times p is 0, then j. Okay. For row 0 it will be just here, for row 1 it will be here, which is I cover the first row, then go to the second row. Okay. So, I am sure you can understand this very easily. So, this is where C element I j is in 1D array, and this is updated with sum, and okay. So, this is one part of the parallelization, other part is here. So, pragma ACC copy in A and B and copy out C. So, this function is still running on CPU. Okay. CPU is running that function. In fact, CPU is like a commander. He just tells this guy, okay, this one you do it. Okay. That is this basically offloading. It is called offloading to accelerator. So, you are best in this, so you do it. Okay. So, that is what here CPU is telling, that this part will go into GPU. So, you see it is quite easy. I mean, if you have sequential code, changing into OpenACC is just straightforward, and there are many operators for reduction. So, for addition it is plus sum, multiplication star, max, min, this for bitwise AND. So, you may have a lot of Boolean variables and you can do AND or logical AND, logical OR. So, this is for Boolean of variables which have value either yes or true or false, but this AND is well also is 0 1, it works with 0 1. Okay. Well, these two are roughly same, but this could be month equal to September. Okay. So, this has a value true or false, right. So, this I can call it x equal to this is allowed in C. Then this guy will say will take value true or false, and here of course AND will not take this month equal to this stuff, x has to be either 0 or 1.